Okay, so I will discuss the next 5 marks question for the PhD part in TIFR to uh, this year. Okay, so let's start with the eighth question first. I will move to seventh question last because I have a confusion in it. Okay, so the eighth question is straightforward. Okay, so consider two relativistic particles, each of mass m, momentum of magnitude p, colliding head-on. So as a result of collision, two heavier particles are produced, each of mass alpha m. So the minimum momentum value p required for this collision to occur. Okay. So the minimum momentum they are asking. So when the heavy mass are produced, alpha m. So you can assume that they don't have any kinetic energy at all. They are at rest. Okay. So then you have the minimum momentum condition. Okay. So both the particles have energy is root under p square c square plus m square c to the power 4. So 2 into E is equal to 2 alpha mc square. Okay, this is the condition for minimum momentum. Okay, because they can have kinetic energy but they don't have, yeah, they don't have because you have calculating the minimum momentum required to create this particle, so they are only created. Okay, so they don't have any kinetic energy. So p square c square plus m squared c to the power 4 is alpha square m square c square. Okay, so you can simply calculate that p is equal to root under alpha square by 4 mc square. Okay, so this is the eighth question. uh, may I forgot to write the ninth question. Okay, let's move to the 10th question. So this is also a very long statement but it is very straightforward. Okay, so they are describing what is cell model and blah blah blah. Okay, so they are writing the spin orbit interaction given by HSO, that is C into L dot S. Okay, C into L dot S. Okay, and C is minus 2 MeV. So what is the energy difference between the two nucleus 1D 5 by 2 and 1D 3 by 2? Okay, so C L dot S is equal to C into L plus S whole square minus L square minus A square by 2. Okay, now they are describing 1D 3 by 2 and 1D 5 by 2. So for this case L plus S, that is J, is 3 by 2, and for this case L plus S, that is J, is equal to 5 by 2. Both are d orbitals, so L value is same and spin is also same. So this, when you take the difference, these two part will definitely not contribute. Okay, so the delta E is equal to C into j 3 by 2 square minus j 5 by 2 square. Okay, so that is equal to j into j plus 1. Okay, so 3 by 2 into 5 by 2 minus 5 by 2 into 7 by 2. Okay, so c by 2 into 5 by 2 into 2 is equal to 5c by 2. Okay, that is, sorry, that is minus 9 x by 2, that is 5 mb. Okay, yeah, now this is question number 11. Okay, so this question I don't have exactly match with the solution, but I will tell you what is the concept. Okay, so when radiation falls in this spring mass system and mirror, it will create some pressure. Okay, so radiation have some pressure. Okay, so if radiation had intensity I, then the pressure is I by C, and if it is absorbed by a surface, then the pressure exerted I by C, and if it is reflected by some mirror kind of surface, then pressure exerted is 2I by C. Okay, this is due to change in momentum. Okay, so if a ball hits the surface and uh, transform in this direction, so it is initial velocity in this direction, final velocity in this direction, so change in momentum perpendicular to the surface is 2p cos theta. Okay, so the similar kind of approach is here. The radiation is kind of a ball, the, I mean, beam of many photons hitting this surface and in an angle theta and reflected back. So the total pressure is 2I by C. So the force is pressure into area, that is 2I by C into area. Okay, so that is equal to K into delta X. So that is a compression of the spring. Okay, so this is the concept. Okay, but of course there should be multiplied by a cos theta because this is the concept. Okay, so hitting this surface and reflected back, with the angle theta. So the change in momentum in this perpendicular direction is a component of cos theta will be added here. Okay, so there will be multiplied by a component cos theta. Okay, so from these options directly you can take this answer, but I will not exactly say that this will be the answer because I have some certain confusion in this. So what is I? I is half c epsilon naught square. Okay, and what is then 2I by c? Epsilon naught E naught square. Okay, so what is force? This is 2I by c. So what is force? Force is PA cos theta. Okay, so epsilon naught E naught is square cos theta into A. So what is delta x? Delta x simply f by k. So you have to divide it by k. So this should be the answer according to me, but according to their options, if you multiply it by root under epsilon naught in both, so here will be epsilon naught divided by root under mu epsilon naught. So it will be c into epsilon naught. So they are having an extra term c. Okay, I think this is not dimensionally correct. Okay, but I don't know. I am not sure. Maybe I am doing some mistake. Okay, so you can tell me. But yeah, from this concept, you can mark this option with 200% confidence without any further thinking. Okay, so it should be linearly proportional to cos theta. Okay. Now this is a IPHD level problem, BSc level problem. You do this problem many times, a repeated number of times in semesters also. Okay, so this is theta one, this is theta two, this is same. So what is the x coordinate of this mass? It is both the length are L. So L cos, sorry, the y coordinate of the mass is L cos theta one minus L cos theta one diagonal direction plus cos theta two. And what is the x coordinate? X coordinate is L sine theta 1 plus sine theta 2. Okay. So what is will be the Lagrangian? Lagrangian is t minus v, that is m by 2 into x dot square plus y dot square. You can take the derivative x dot y dot. Okay, and simply minus v is equal to minus mg into y. Okay, so if you do this calculation you will get option A. Okay, you will be doing repeatedly this problem. Okay, this is a very common problem, I mean universal problem. Okay, yeah. So now this is another problem from basic nuclear physics. Okay, so consider an alpha decay 224 U2 at rest 220 thorium. Okay, uranium to thorium, and atomic masses are given below. Okay, so what is the estimate of kinetic energy? Okay, of alpha particle. So you have to calculate the alpha particle. Okay, yeah, kinetic energy. So first you have to calculate what is the q value. Q value is simply the mass of uranium minus mass of thorium minus mass of alpha into this 931.5. 931.5. So if you do this calculation you will get 8.5698. Okay, but this is the total q value, not the kinetic energy of the alpha particle. So you can mistakenly take this answer, but this is not correct. We have to calculate the kinetic energy of the alpha particle. So go with the momentum conservation and energy conservation. So initially the uranium is at rest and it will go to thorium and alpha. Okay, so the momentum will be conserved, both the magnitude of momentum will be same. So what will be the kinetic energies of the two particles? Q, and the Q value is kinetic energy of thorium plus kinetic energy of alpha. Okay, so P squared by 2m into thorium is equal to P squared by 2m alpha into m alpha by m thorium. Okay, so this is kinetic energy of thorium, this is kinetic energy of alpha, this is 4, this is 220 is equal to 50, sorry, k alpha divided by 4 5 5 55. Okay, so k alpha will be 55 by 56 into q value. Yeah, so the q value is k thorium plus k alpha. Okay, so if you calculate this you will get this answer 8.4163. 4163. Okay, so this will be the answer. Okay, so these are the all last two questions I till didn't done. And the now let's move to the seventh question. Okay, this I have a little bit confusion. Okay, because it is not exactly matching for me. So they are telling the consider a free particle in three spatial dimensions, p square by 2m, and this is the initial wave function in three dimension, gamma by pi to the power 3 by 4 e to the power minus gamma r square by 2. And what is the probability density of finding the particle with energy E at time t? Okay, so you have energy E at time t, so you have to do the time evolution of the wave function. And what is the probability density you have to find? Okay, so they already given the hint. You have to get what is the hint, and if they don't have given the hint, then you also should know that how to approach this problem. So the in this problem, see, there is no spatial part. Okay, there is no Vx. Okay, so only the kinetic energy part. The energy is basically the kinetic energy, which is directly the p squared term. Okay, so if you have to do the time evolution, then you must have to convert phi h to phi p. Otherwise, you can't do the time evolution. Okay, so as E is only a function of p square, that is kinetic energy. So you must have to convert this. Okay, otherwise you can't do the time evolution. Okay, so now what is phi? Phi is gamma by pi to the power 3 by 4 e to the power minus. Now be careful. R square is x square plus y square plus z square. Okay, this is the phi 3 by 4 here. So now what is phi p? You have to do the Fourier transform to go into momentum space. Okay, so there is some constant factor, probably root under 2 pi h cross for each spatial dimension. So there will be a 3 gamma pi to the power 3 by 4 e to the power minus gamma x square by 2 into e to the power minus I k1 into x. K1 for, I am telling that k1 is for x dimension. That means k1 is equal to k suffix x. This is for x part. Okay, dx. Okay, this part. And similarly for gamma y square by 2 into e to the power minus I k2 y. And similarly for the z part. Okay, and then multiply by divide by root 2 pi in all this, and you will have a 2 pi to the power 3 by 2 here. Okay, now look what they are telling. They are telling you this value. Okay, they are telling you this value. So now directly put this value. So 2 pi by 2 pi h cross to the power 3 by 2 gamma by pi to the power 3 by 4. Now simply, what is this value? 1 by gamma e to the power minus k square by 2 gamma. So 1 by root under gamma, yeah. 1 by gamma to the power 3 by 2 into, so root under gamma, but there is three terms, same. Okay, so e to the power minus 1 by 2 gamma k square. Okay, so k1 square plus k2 square plus k3 square. So this overall k square. So k1 square plus k2 square plus k3 square is k square. Okay. So what is your phi? Phi is 1 by h cut to the power 3 by 2 gamma pi to the power minus 5p. Okay, this is 5p minus 3 by 4, I guess. Yeah, minus 3 by 4 into e to the power minus gamma k square by 2. Okay. Now what will be the time evolution? So 5p at t. So it is 1 by h cross to the power 3 by 2 gamma pi to the power minus 3 by 4 e to the power minus gamma k square by 2 into e to the power minus I e t by h cross. Right? Now what is e? E is equal to h cut square k square by 2m. Right? So what is e by h cross? E by h cross is simply h cross k square by 2m. So what will this term will give you? This term will give you e to the power minus k square by 2 into gamma plus I h cross by m. Right? This is the term you will get. So this is phi pt at time t. So you have to calculate the probability density. So mod phi pt is square, right? Mod phi pt square. So 1 by h cut cube gamma pi to the power minus 3 by 2. Now this is a complex part. So if you multiply it with this complex conjugate, it will simply give you 1. So it will simply minus gamma k square. Okay. Now k square is 2m e by h cut square. So this term will e to the power minus gamma 2m e by h cut square. Okay. So from the given options, this is the most suitable, I guess, because this term is matching, this term is matching. But I don't sure about these terms. Okay. So this term I have a bit confusion. Okay, so these two terms are not definitely correct because there is some t, there is some other root under 2me, but why this term is there, I am not very sure. I have to inspect a little bit more. Okay, so if I get anything, I will tell you in the next video. Okay, so yeah, thank you.